Hello, this is Mickey. Today we will talk about 5G protocol stack, the continuation of the diagram shown below last time. And then we're going to look at the PDR, which are packet detection rules. And then lastly, we're going to look a little bit around the interfaces in 5G. So based on the diagram in the last call, we had some terminologies, and those terms are I'm going to go through right now. So one term is HTAP. So HTAP operates in the RRC, so the radio link control layer of the protocol stack. Its main role is to adapt the data received from the transport layer to be suitable for transmission over the wireless air interface. Another term is the PTCP, which it operates at the uppermost layer of the protocol control lane, RRG, and it's responsible for various implementation functions related to the data transmission and the reception between the user equipment and the base station, which is the Shinobi infrastructure. RRC, it's another one, which one manages the logistic link between transmitting and receiving devices, which is also the radio link control layer. Then there's the MAC. The MAC layer we talked before, but it handles the access to the physical transmission medium. And then there's the physical layer, which one is the PHY. This is the lower layer of the protocol stack, and it deals with the actual transmission and reception of electromagnetic electron and magnetic signals over the interface. And the last one is NAS, which one handling the control plane signal and the mobility management between the UE and the core network. So let's talk about a little bit about packet detection request. So the importance of effective it's that it's efficient packet detections and ensures network security and QoS. So quality choice and QoS will be discussed in the next call. So the key elements of the 5G packet detection are header inspections, which are source and destination address, protocol information, and QoS parameters. Pattern matching is another key element, which is a deeper packet inspection and signal page detection. And the last one, it's anomaly detection for the key element of the pattern matching. Aside from that, there's service-specific rules, which can towards radio data and IoT, and different handles for each service type. So if you're looking for some samples of packet detection rules, I listed 4. So rule 1 would be on VIOP traffic, which is means identify zip and slash tip protocols, and prioritize QoS for VIP calls. Another rule can be video streaming, which detects streaming protocols, HTTP slash QUIC, and allocate sufficient bandwidth for smooth playback. Rule 3 might be IoT device traffic, so identify COAP and MQATP protocols and apply security scrutiny for device, IoT devices. And then the last rule that comes critical data traffic, which recognizes the TLC encrypted packets and ensure low frequency for financial transactions. So these are some examples of packets, uh, um, packet loads detections that can come. There are more, but here's just a few to show. So going back to the 5G architecture, we talked about user plane and control plane. We talked about AMF, USF, SMF, and the UPF, and now we're going to talk about the N, where it says N1 and 2 and 3 and 6. So these are interfaces, and this is where we're going to talk next. So starting with the first one on N1. So this is the between the LAN and the core, and it's responsible for the user plane data and the control signaling between the 5G base station, so GNP, and the 5G core network. And it handles the functions like the mobility management, session management, QoS enforcement, and enables efficient communication between wireless network and the core infrastructure. Then we will get to like N2 interfaces where you're talking to the LAN, which filtrate into Chinope's communication for functions like handover and radio resource management, and helps in maintaining seamless connectivity as a user moves between different base stations, and enable efficient load balancing exploitation within the radio access network. Then we have N3, which is an internal CN, the core network. So this one is connected to different network functions within the core. It handles functions like mobile management and session management between different parts of the core network, and ensures smooth communication and cooperation between various network functions. Then we're looking at N6, which one is linked from external data network, such as internet to the 5G core, and provides a connectivity for users between the external network and the core network, and enables data exchange services like internet browsing, media streaming, and cloud services. So those are the main ones, interfaces for 5G, but there are other types which we have to go over right now, which are air interface known as the radio interface, which connects the user device to the base station in 5G, So it supports the high rate data rates and low latencies and improve spectrum efficiency compared to various generations. Another one is anti-LAN interface, which was the next generation of radio access network interface, and it connects the GNOP, so the new radio base station, to the 5G core, and enables which can button enables the device the delivery of the user data and control information between the radio access network and the core network. That is an interface, which interface between two GNOVs within the same network operator, supports functions like handover and load balancing, and enhance network flexibility and perform optimization. E1 interface, it's another one that could come up. E1 interface between the GNOP and the 4G evolved uh, node beats. And if infiltrate between the internal working between 4G 5G network, aiding in the transition phase. XX, it's a connection between the UPF and into 5G data network, and responsible for policy and control shading for the data device. And two related covered, but just talks about the mobile related functionality. Then we have the F1, which is between the CU, the central unit, and TU, which is the distributed unit in GNOP, and facilitate the split architecture and support flexible development scenarios. And that's all for today. If you have any questions, please let me know in the chat below. Thank you.